Okay, there was another question regarding problem three, written problem number 3 in the old exam. So the question is about a car moving with an acceleration of 1 meter per second square for 20 seconds, and then it brakes, so slows down at with an acceleration of 0.5 meter per second square, and it is asking to draw different graphs like velocity versus time and acceleration versus time and x versus time. So let's do this. First we have our time axis, and for some reason they asked to do the velocity first, so okay, sure. And for this part it doesn't, they don't ask a quantitative graph, but just a schematic graph. So let's say this is 20 seconds. This is the first event, and then the rest is like we call this let's call this one T0 at this point, and I call this one T1, and it ends at T2, and we call this one delta T. Oh, maybe we don't need, actually this is a delta T and delta T prime, something like that. We'll see. I'm just doing it as I go, so if something comes up I may change these things. And this is velocity first. So at the beginning the acceleration is 1, so basically kind of the slope of this line is supposed to be 1. So I mean, of course I have like a nice grid here, so I can say, oh, this is the acceleration 1. But again, as I said, it doesn't, they don't need a quantitative it's supposed to be a schematic, so it's all right. But then I'm trying to do my best to be more quantitative. And then the next part is the acceleration is 0.5, so the slope of this line is kind of 0.5. I ended up being at this point, so basically this is my time. So first part of the motion, and then the second part. I'm happy about this. Oh, maybe I have to do seconds here. Now the next graph is acceleration, right? That's right. So again, versus time, which is a second, and then acceleration, which is meter per second square. And like so I follow the line here, so because the time axes are the same, so let's say this is 1 meters per second square, and then it all of a sudden it goes to 0.5. Oh, maybe I should use a different color. So this is the first one, one, and this is the second part of the story, and this is 0.5. Basically negative, but you see this is below the time axis, so this is already tells you this is negative. Now let me do the it's so funny when I make these videos, but it's all good. T, and okay, now this is the kind of part that you have to be more careful. Meters, right? So we know it is accelerating, so it's a kind of a part of a parabola like that. But then the initial condition is that, do you see it? Yeah. the initial condition is that, oh, at the beginning the speed is 0, so the slope has to be 0, so it starts something like that, right? So basically it's a parabola like that, but it stops at this point, which is t1 and t2, right? And then eventually it slows down, so up to here, but with a, you know, with a small kind of, you know, pace, something like that, and it stops. So this is also a part of a parabola like that, you know, but it's slowing down, so it's this way. So the slope is 0 here, and the slope is 0 here. These are the important parts. And this is curving up, meaning that it's accelerating, and this is curving down. There you go. That's the first part of the problem. You know, usually it's good to say it's part A. Maybe I can do the part B just right here. Part B. So there are different ways of doing part B, and in the answer key that I posted online, there's a solution which I, you know, for some reason I don't know, that's not my favorite way of solving it. I would like to do my own kind of, you know. So this is T1 and this is T2. So if you don't mind, I call this one, this is delta x1, and this much is and this is delta x, or maybe I'll do it like that, delta x2, and this is the whole, right? Displacement, which is basically delta x1 plus delta x2. So what are we looking for? Find the total time required for, I see. Okay, let me, yeah, just to be consistent, I would like to call this one delta x, delta t1 and delta t2. Yes, these naming are not really crucial, but I wanted to be consistent with this part here. Okay. For the first one, I think, what do we know about this? We got oh, I see. Okay, there you go. So we need to find the total time. So we have the time for this part, but then we don't know the delta t2. But how do we know, how do we get to delta t2? Delta t2, it starts from here with that, but we don't know the initial velocity of this one, and we don't know the position. So maybe it's a good idea to find the velocity at this point. But how do we find the velocity at this point? We should consider this part of the story. So let's say if we call this one v1, basically this is v1, right? v1 is equal to v0 plus a delta t1, and v0 is 0 plus a is 1 times 20, and v1 is going to be 2 meters per second, and don't forget your units. Now we have this initial velocity, but the acceleration is different, so we can easily actually find how long it takes to reduce this velocity to 0 with the new acceleration. So we say v2 at this point is equal to v1 plus, oh, maybe I should use a underlined 1 for the acceleration during the first part, and a2 for the acceleration during the second part. So and is going to be equal to, you guys, yeah, 20 and the acceleration is negative, so minus 0.5 delta t2, which I don't know. But also we know that v2 has to be 0 because it stops there. So equal 20 minus 0.5 delta t2. If you do the calculation, delta t2 would be 40 seconds. Okay, I hope this makes sense, and I hope I should post this on Canvas. Okay, next step is asking us to find the total distance. So total distance, I want to go back to this graph. Total distance is basically the distance traveled in the first part plus the distance traveled in the second part. So this is the total distance, and I call it delta x. So let's do delta x1 is 1/2 a1 delta t1 squared plus v0 t delta t1. I'm replacing all the numbers because I know acceleration is 1 and time is 20 plus at the beginning there's no velocity, so this is going to be 200 meters. Delta x2, we get 1/2 a2 delta t2 squared plus this one is v1 delta t2. So this is important because at the if I can put these two side by side, maybe something like that. Yes. Okay. So I'm using this formula, and the initial condition for this formula is basically t1, which of my initial velocity is v1, and also the time interval is delta t, so I'm using the delta t2, so delta t2. So yeah, I believe some of you are confused about all these the initial velocities, and so this is a good example for a case like that. And then I have is equal to 1/2, and the acceleration is actually negative, and the delta t2 it is 440 plus v1 I think we got 220 times 40, so it's like 1/4. 400 is 16 plus 800, and the answer is going to be 400, I think so, meters. So, and at the end, delta x is equal to delta x1 plus delta x2, and is equal to 246. I think that is it. Yeah, this should be that's the last part. I hope you enjoyed the video.